In Java, we have primitive types as well as objects. There are 8 primitive types in Java. For example, short, int, byte, long, double, float, boolean. And we have object class for these primitive types also known as wrappers. For example, integer for int, character for char, and so on. We will first look at how sorting is done for these primitive types. So let's create an integer array first. Say int array equal to, and let's populate this int array with values, and the value could be randomly populated. Now, in order to sort this array, Java provides you Arrays.sort. This Arrays.sort have different constructor versions for byte, char, double, float, int, object. So here I've created an int array, so I will use an integer version of the sort. Now let's print this sorted array. Since we need to print as a string, so I'm using toString method of arrays and passing array as an argument to toString. Save the class and run the class. So if you see, I have created the array, and this array was random numbers like 1, 5, 6, 9, 4, 3, 2, 10, and then I have used array.sort method to sort the array, and the result is 1, 2, 3, 4, 5, 6, 9, 10, that is in ascending order. So this array.sort method gives you the result in ascending order. So with any primitive types like char, int, double, short, you can sort using arrays.sort, and the result would be ascending order or natural order. By the term natural order or ascending order, I mean for alphabet it would be start from A to Z, and for numbers it will start ascendingly like 1, 2, 3, 7, 8, 9, 10. Now let's create a list of integers to understand how for object this sorting would be done. So creating a list here of integer type. Integer class is a wrapper for int primitive type. I am creating an array list here. Now adding objects to this array list and adding the value randomly. Here we have added the values to the array list, and the values are 1, 5, 10 to 7. So in order to sort a collection of a type integer or any custom type, we can use collections.sort method provided by Java utility package. Now all the methods in this collections class inside Java utility package are static methods. So using collections.sort list, let's print this list. Commenting the first system.out.println. Save the class and run it. Now if you see, the values added in the list are 1, 5, 10 to 7 in the same order, but the result was 1, 2, 5, 7, 10, which is again a natural sorting order or ascending order, you can say. So if you want to sort primitive type, you can use arrays.sort, and this sort method has different flavors, like it would be byte, char, int, float. If you want to sort an collection on natural order, you can use collections.sort. But these integers or any other wrapper class are inbuilt inside the JDK. What if I use a custom object class? Let's see. So add a custom object class in your package primitive and object. So here we have employee.java, And this employee.java class has three fields: ID, name, and salary, and a constructor generated using the fields and a getters and setters for the fields. So let's try to sort this employee.java. For that, we need to create a list of employee. So creating a list of employee. Instead of integer, I am passing the employee, and let's say it will be an employee list, creating an array list. Now to this employee list, we will add some employees. Since the employee class contain ID, name, and salary, so accordingly adding the values. Let's add few more values to this. Here we have created a list of employee and added the few employees to employee list. So let's sort this employee list using collections.sort. So changing the argument to employee list. If we add employee list, we are seeing we are getting an error here and the error is this sort method is not valid for employee. But why? We have sorted right now an integer which is a wrapper for int primitive type, and this integer is an object class. But why not we can sort for this employee class? To understand that, if you go to the implementation of this integer provided in the JDK, you will see that this integer class is implementing java.lang.comparable. This comparable is a functional interface in Java and provides you a compare to method for sorting of custom objects or say objects in Java. So the wrappers in the Java or provided in the JDK all have implemented internally. So we can also implement this comparable class. So go to employee.java. Here implements comparable interface. Instead of T, you can pass employee because it is of type employee and add the unimplemented method. So if you go down, you can find that we have compared to method which has only one argument, that is type of employee. So let's say if you want to sort on the basis of ID, we can use or write the logic as this dot ID minus use the argument provided in the compare to method o dot get ID. I will use minus because this is an int type. So if you have a string, you can use compare to. So this logic, this dot ID minus o dot get ID is usually written -1, 0 or 1 depending upon the values. So if this dot ID referring to the current ID is greater than o dot get ID, it will return 1. If it is equal to o dot get ID, it will return 0, and if it is lesser than, it will return -1. So let's go to sort driver.java, and if you see there is no error right now here. So let's save the class and run. We need to change to employee list to see the result. Now if you see the console, you are seeing hexadecimal representation that is not a string representation. So let's add a toString method to employee class. So the toString method is provided in the object class and used for string representation. We can use all the fields in the employee class so that I can get this logic for toString. Now save the employee, again go to sort driver.java and run. So if you see, I have sorted on the basis of ID, and the ID that I have added in the employee list was 1, 4, 2, 7 and 6. But the result that I'm getting is ID as 1, then 2, 4, 6 and then last is 7. So again the sorting is done on the basis of natural order sorting. So what if I want to sort on the basis of the salary? To do that, let's again go to employee.java and change the logic here. So instead of ID, it could be salary and compare with salary. So it will be get salary. Now save the employee.java, go to sortDriver.java and again run it. So if you see, the employee list contains salary as 1000, 9000, 3000, 5000 and 2000. But on the result, the salary was sorted and was 1000, then 2000, then 3000 and so on. So if you have noticed, there are two things. First, if you want to sort an object in Java, you need to implement comparable interface, and those classes that are already built in the Java or available in the JDK have implemented the comparable interface. If you are creating a custom object class like employee, you need to implement comparable interface and pass employee to this comparable interface. So you are changing your class structure because you are adding comparable interface at the class level. And this comparable interface, that is again a functional interface, provides a compare to method which have only one argument, and the logic you are comparing with the current reference using this with the object of employee that you pass as the argument to the compare method. And as we have seen, we have sorted on the basis of ID and the basis of salary, but while doing so on the basis of salary, we have to change the logic. So this comparable interface we can only use for single way of sorting. We can't use for multiple way of sorting. If we need to do so, we need to change the logic. To do sorting on multiple fields, Java provides you comparator interface. So let's have a look at comparator interface. To implement comparator interface, it could be done in two ways. Either you can create a static field and return the instance of comparator, or you can create a class, and with this class you can implement comparator interface and use that class in collection.sort. So let's add a static method for comparator. Public static comparator. Inside comparator we'll pass the custom object class, that is employee in our case. Let's say I want to sort on the basis of ID, so I'm writing ID comparator, which is just a name, and here I am returning anonymous implementation of comparator. Again pass employee to this comparator. So we have added a compare method which takes you two arguments of employee, that is E1 and E2, and the logic for ID comparator is E1.getID minus E2.getID. Let's save this employee class. Go to sortDriver.java. Now I want to sort on the basis of ID. So let's say use collections.sort. Now this sort method has two versions. That first version of sort would take list, and second version take list as well as comparator. So using that, passing this employee list as an argument along with the comparator. Since we have created a static methods, we can use with the class name itself employee.id comparator. Now we will print this. Run the program. So if you see again, the result is sorted on the basis of ID. So with use of Comparator Interface, which is a functional interface, we can sort based on the different fields. Now let's see how we can do so using class implementation. So create a class inside primitive and object. So with this name comparator, let's implement your comparator interface. Again pass employee to this comparator and add the unimplemented method. Now since we want to sort on the basis of name, so use o1.get name, and name is of a string type, so using compare to and passing o2.getName. So again this compare to will return either -1, 0 or 1 depending upon whether o1 get name is higher, lesser or equal to o2.getName. So if o1.getName is smaller than o2.getName, it will return -1. If it is equal, return 0, and if it is greater than o2.getName, return 1 positively. Let's use this name comparator. So go to sort driver.java. Here with collection.sort we can pass employee list, and instead of using employee.id comparator, since we have created a complete new class, so we can pass the object of new name comparator. Now let's run the class. So if you see the order in which we have added to the employee list, it was A, H, D, C, B, but the order in the result is A, then B, then C, and then D. So this is again a natural sorting using comparator interface. If you want to do sorting on the reverse order, what you need to do is just reverse this o1.getName.compare to o2.getName. Let's try that. o2.getName.compare to o1.getName. Save the comparator. Again go to sort driver.java and run it. Now you can see the sorting was in descending order, that is highest then to lowest. It was H, then D, then C, B, and the next one was A. One point you have noticed that this comparator interface, whether we are implementing through a static method or using class, is not interfering with the class name. We are not adding it on the class definition itself. It is not interfering or disturbing the class structure. Second point is we are doing sorting based on multiple fields. It is not limited or restricted to use of only one field. So in order to summarize the comparator and comparable, first basic key point is comparable is in java.lang package, comparator is in java.util package. We can see with also here comparator is in java util package and comparable is java lang package. Then for doing single sorting, we can do so using comparable interface, and this comparable interface will always implement natural order of sorting. If you want to do sorting based on multiple fields like ID, name, salary, you need to implement comparator interface. And this comparator interface provides you compare method which have two arguments and both arguments are of object type. It may be the case that you are using any third-party APIs or code that you could not change and you want to sort. So in that case, you could not use comparable. because with comparable you need to change the structure of the class. So for that case you can use comparator interface. So this was all about comparator and comparable.